In this video, we will apply the formulas we've learned earlier to compute the expected value and the variance of a particular random variable x. So what we have here is a probability distribution of x with three possible values, -1, 2, and 5. Now note that I intentionally have -1 here to show you that a variable can take on negative values as well. Right. So from this table, we know that x is equal to -1 with probability 0.4 is equal to 2 with probability 0.25 and is equal to 5 with probability 0.35. All these probabilities are between 0 and 1, right? And if you sum them up, you get 1. And so this is a valid probability distribution that we have here. So now whenever I do this kind of calculation, I like to construct a table that looks like this, but obviously you don't have to, right? If you prefer plugging in numbers into the formula, that's fine with me, as well as you show me all the work. So let's fill out this table to see how we can use this table to find the expected value and the variance. So in this third column here, I have xk times the probability that x is equal to xk. So what we want to do here is we want to take each of the xk's, so each of these numbers, right, and multiply by its probabilities. So we get -1 times 0.4, that gives us -0.4. We have 2 times 0.25, that gives us 0.5, and then we have 5 times 0.35, that gives us 1.75. Right? But then note that for each xk, that's exactly what we need to find the expected value, right? And so if you sum up all the numbers in this column, you get the expected value, e of x or mu of x, and so that's going to be equal to -0.4 plus 0.5 plus 1.75, which is equal to 1.85. Now in the next column here, we have the column for xk minus mu of x. So what you want to do in this column is you want to take each of the xk's, so each of these numbers, -1, 2, and 5, and subtract the expected value from it. So in other words, we're going to have -1 minus 1.85. That gives us -2.85, right? Then we have 2 minus 1.85. That gives us 0.15. And then 5 minus 1.85. That gives us 3.15. Now in the next column, we have xk minus mu of x all square. So in order to fill out this column, all we have to do is to square whatever we got in the previous column. Right? So we're going to have -2.85 all square. That gives us 8.1225. Then we have 0.15 square. That gives us 0.0225. And then we have 3.15 square, and that gives us 9.9225. Now note that the numbers in this column are these in the formula, right? So it's the xk minus mu of x all square, okay? And so what we need to do now is to multiply each of those numbers by the corresponding probabilities, right? So in this last column, you want to multiply each of the numbers that you just computed by the probability that x is equal to xk. So here we're gonna do 8.1225 times 0.4, which gives you 3.249. Okay? And then for the second value, you're gonna have 0.0225 times 0.25. That gives you 0.005625. And then for the last value, you're gonna have 9.9225, and you multiply that by 0.35. That gives you 3.4728. Let me rewrite this. So we have 3.472875. Now the idea is, in order to get the variance, you want to sum up all the values in this last column. So if you sum up all the values in this last column, you have the variance sigma x squared, which is going to be equal to 3.249 plus 0.005625 plus 3.472875, and that gives us 6.7275 as the variance. So in this video, we looked at a specific problem where we applied the formula for the expected value and the variance to find the expected value and the variance for a random variable x.